So there are a few different ways to draw the hexane structure. You can see here on the screen we have carbons in a straight line, all bonded with single bonds, and hydrogens surrounding them. Whenever we have a name that has ANE at the end of it in organic chemistry, that means we're going to have single bonds and only carbons and hydrogens in the structure. Hex, that's the prefix that means 6. We have 1, 2, 3, 4, 5, 6 carbons, all connected by single bonds to each other and the hydrogens. Experimental data tells us that the atoms don't actually line up neatly like this in the real world. Something called valence shell electron pair repulsion theory tells us that they're going to spread out. Those orbitals are going to try to be as far away as possible from each other to minimize that negative charge, those electrons that surround them and create the orbitals. Because of that, hexane's going to look something like this. We know that atoms aren't static like we draw them here. They're actually moving, and we can visualize that and see the motion of the hexane molecule at room temperature. So here you can see it's moving, and the methyl groups on the end actually are spinning some. This adds a new dynamic element to the idea of the hexane structure. Finally, there's one more way that we can actually draw hexane in 2 dimensions, and this is used quite often by organic chemists. It's kind of a shorthand. Here, the ends and then the junctures represent a single carbon atom. So we have 6 of these. We don't draw the hydrogens. We know that since it's an alkane, like hexane, and it's only carbons with single bonds and hydrogens, that we can figure that out pretty quick by just thinking about how many electrons to fill the outer shell. 2 for hydrogen, 8 for carbon. So we really don't need to draw that, and you get very used to thinking about this. So this is one way that you may see it. If we were to draw the hydrogens, there'd be 3 on the end and then 2 at each of these junctures. So that's a little bit about the structure of hexane. This is Dr. B, and thanks for watching.